going to do question 1, where we are asked to solve for x for these problems here. So 1.1.1, so we're having x squared minus 2x minus 24 is equals to 0. So the first step we're going to do is we're going to factorize this problem here and equate to 0 and find the factors of x squared, which is x and x. Factors of 24 such that they give us the middle term is 6 and 4, right? The larger number takes the sign of the middle term, so this is going to be negative and this will be positive. So x minus 6 equals to 0, or x plus 4 is equals to 0. So we transpose the 6 to the other side and the 4 to the other side. We have x being equals to 6, or x being equals to minus 4. So these are our solutions of x. In 1.1.2, we are going to solve this problem here and correct to 2 decimal places. So whenever we see these words of correct to 2 decimal places, it tells us that we need to use a quadratic formula. So we're having 2x to the power of 2 minus 3x minus 3 is equals to 0. And our quadratic formula is x equals to minus b plus or minus the root of b squared minus 4ac. Then we divide by 2a, of which our value of a is equals to 2, our value of b is equals to minus 3, our value of c is equals to minus 3, right? So we're going to substitute these values in our problem here. So we're going to have x being equals to minus our b, it's minus 3, plus or minus the root of b, which is minus 3, squared minus 4, our a being equals to 2, and our c being equals to minus 3. Then we divide by our 2 into 2. Then the solutions that we need to find is x being equals to 2.19, or x being equals to negative 0.69. So these are our solutions of x correct to 2 decimal places. So now we're going to do 1.1.3, where we're going to solve for x for this expression. Please note that this is an inequality sign, so we're going to solve for x differently compared to previous problems. So what we have here is x squared plus 5x less than or equals to minus 4. So we're going to transpose this minus 4 to the other side, this side here. Then we will have x squared plus 5x plus 4 less than or equals to 0, right? So we're going to factorize this problem here. Less than or equals to 0. So the factors of x squared, it's x and x. Factors of 4 such that they give us the middle term, it's 4 and 1, right? And the middle term is positive, so we can just make everything positive. And then we're going to write our critical values. Our critical values is x plus 1 equals to 0, or x plus 4 is equals to 0. So x will be equals to minus 1, or x is equals to minus 4. So these are our critical values, right? So we're going to draw our number line and present our critical values. So we have our critical value of minus 4 and our critical value of minus 1, right? So I'm just going to write critical value, right? So what you're going to do here is, because we want the solutions of x, we need to use our critical values to interpret the solutions of x. For us to do that, we need to present, or we need to test rather, certain values of x and see if they're going to give us a solution that is less than or equals to 0. If you see here, we want solutions of x such that they are less than or equals to 0. So anything that is less than or equals to 0, it's negative. So we are more concerned of a solution that is negative for this problem here. And then we're going to conclude the solutions of x. So the first step that we're going to do here in this number line, we're going to test values that are before our critical value. So in this case, any value that is before minus 4, it's minus 5. You can test that value here. And then we need to test values that are between our critical values. So let's test minus 3. And we're also going to test values that are just ahead of our critical values, which in this case we can test any number. I'm just going to say 2. So as you're going to test, what you're going to do is this. These numbers that are in purple, what you're going to do, you're going to test them in this original equation here. So you're going to put, for an example, we have minus 5, right? So you're going to substitute x equals to minus 5 here and here, and try to identify the sign that you're going to get when you substitute these values. So you're going to do the same for minus 3 and 2. So the sign that I got when I substituted in the equation for minus 5, I got a sign of a positive. So meaning that any values of x that are less than minus 4 give me a positive solution of y, right? And then I substituted minus 3 and got a negative. So meaning that any value of x that is between minus 4 and minus 1 of our critical values will give me a negative solution of y. And I also substituted my positive 2, rather this positive 2 here, and I got positive solutions of y, meaning that any value of x that is greater than our critical value of minus 1 will give us a positive solution of y. And remember that we are interested in the negative solutions of y, right? Since we have a sign, an inequality sign of less than or equals to 0, right? So looking at our number line, where is a negative sign? It's this one, right? So meaning that this negative sign lies between our critical values. This is the first critical value and this is another critical value. So you can conclude using the sign. So you can simply say x lies between minus 4 and minus 1, right? So these are our solutions of x for this problem here, since x lies between minus 4 and minus 1 because our y values are negative in this case. Okay, so now we're going to do 1.1.4. So we're going to solve for x for this expression here where we're having a sad form, right? So whenever you have a sad form, towards the end of the problem, please check if your solutions of x are correct, meaning that you're going to test if the left hand side is equals to the right hand side. So we're having x plus 28 and it's inside a square root and it's equals 2 minus x, right? So the first step we're going to do here, we're going to square both sides, and then we're going to have x plus 28 is equals to 2 minus x, right, squared. So what you're going to have is x plus 28 is equal to, so you're going to expand this right hand side, so it's going to be 2 minus x and 2 minus x, and then we're going to multiply out this 2 minus 2 multiplied by 2 rather, so it's going to be 4, and then 2 multiplied by x is going to be minus 2x, and then this minus x times this 2 here, so it's going to be minus 2x, and then x multiplied by x, which both are negative, will give you a positive x squared, and then here it's x plus 28, right? So we're going to have x plus 28 is equals to 4 minus 4x plus x squared. So we're going to transpose whatever that is on the left hand side to the right hand side. So you're going to have x squared minus 4x plus 4, and then we have minus x minus 28 is equals to 0, right? So we're going to have x squared minus 4x minus x plus 4 minus 28 is equals to 0, and then x squared minus 5x minus 24 is equals to 0, right? So then we're going to factorize this problem here. Find the factors of x squared, which is x and x, factors of 24 such that they give us the middle term, so it's going to be 8 and 3. So the bigger number takes the sign of the middle term, so it's going to be negative here, and here it's going to be positive. Then our solutions of x is x plus 3 equals to 0, or x minus 8 is equals to 0. Then x is equals to minus 3, or x is equals to 8. So these are your solutions of x, but remember I said whenever you have a SAT form problem, you have to test your solutions of x and see that they apply, they are correct. So I did test both my x equals to minus 3 and my x being equals to 8, and I found that x being equals to 8 is not a solution of x. So only x is equals to minus 3 is the solution of x. We're going to do 1.2, where we are asked to solve for x and y simultaneously using the given equations here. We're having 2y being equals to 3 plus x, so this would be our equation 1, and we have 2xy plus 7 being equals to x squared plus 4y squared, right? So this would be our equation 2. So now we're going to create equation 3 using any of the two equations, but I advise you choose an equation that is simpler. So this top equation, which is equation 1, looks simpler to create equation 3, right? So we're just going to simply transpose this 3 to the other side, and we'll remain with x. So it's going to be x being equals to 2y minus 3. So this would be our equation 3. So we're going to use equation 3, substitute it in equation 2. We're going to use equation 2 as for solving. So whenever we see x, we're going to substitute with 2y minus 3. So we're going to say substitute equation 3 into equation 2, right? So we're going to write 2, instead of writing this x here, we're just going to write this expression here of 2y minus 3. So it's going to be 2y minus 3, and then multiply by y plus 7 is equals to, so instead of writing this x squared, we'll write the same expression. So it's going to be 2y minus 3 all squared plus 4y squared, right? So what we'll do here is we're going to multiply the y inside the bracket, right? And we're going to expand this expression here. So let's first expand this expression here. So let's first expand this expression here. So we're going to have 2 into 2y minus 3 close bracket multiplied by y plus 7 is equals to 2y minus 3 and 2y minus 3 plus 4y squared. So we're just gonna multiply the y inside the brackets and do the same here, multiply using our FOIL method, right? So we're gonna have 2 into 2y squared minus 3y close bracket plus 7 is equals to, so this 2 multiplied by this 2y, 2y is going to give us 4y squared, and the 2y multiplied by minus 3 is going to give us minus 6y, the same thing here, minus 3 and 2y is going to give us minus 6y, and then minus 3 multiplied by minus 3 is going to give us 9 plus 4y squared, and then we're just going to multiply this 2 inside here, and we will have 4y squared minus 6y plus 7 is equals to 4y squared minus 6y minus 6y plus 9 plus 4y squared. Now we're just going to collect like terms. So if you see here, we have 4y squared and 4y squared and another 4y squared, but this one is on the other side of the equation, so this is 7. So what you're going to do is we can cancel out this 4y squared and this one here, right? Because if you take one to the other side, it's going to be negative. So we remain with this 4y squared. So we're just going to write 4y squared, and then we collect like terms, minus 6y minus 6y, and here it's minus 6y, right? So if you transpose this minus 6y to the other side, it's going to be positive. So you can also cancel out with this one here, right? And then we remain with only 1 minus 6y, and then we have plus 7 and plus 9 here. So we're going to transpose this plus 7 to the other side. So we will have plus 9 minus 7 and equals to 0. So it's going to be 4y squared minus 6y plus 2 being equals to 0. Then we're just going to divide by 2 all sides, and we'll have 2y squared minus 3y plus 1 equals to 0. And then we factorize to find the factors of 2y squared. It's going to be 2y and y, right? So let me write it properly. So it's going to be y, and then the factors of 1 is just going to be 1 and 1. The signs is going to be negative and negative, so that when we add 2y with this y here, will give us the middle term, which is minus 3y. So to find our solutions of y, we're going to say 2y minus 1 being equals to 0, or y minus 1 equals to 0. So it's going to be 2y being equals to 1, or y being equals to 1, and then divide by 2 here. We have y being equals to 1 over 2, or y being equals to 1, right? So we have our solutions of y, but we need solutions of x. Remember that x, which is our third equation, is equals to 2y minus 3. So we're just going to substitute both values of y to find the values of x, right? So the value of x when y is equals to 1 over 2, x is equals to 2 into 1 over 2 minus 3 being equals to, so this 2 here will cancel out this 2, so it's going to remain 1 minus 3 being equals to minus 2, right? So when y is equals to 1, and then x is equals to 2 into 1 minus 3, so it's going to be 2 minus 3 being equals to minus 1, right? So these are the solutions of x. It's going to be x being equals to minus 2 and x being equals to minus 1. So these are our solutions of x. We're going to do 1.3, where we are told that the roots of an equation are x being equals to minus n plus or minus root of n squared minus 4mp divided by 2m. where m, n, and p are positive real numbers. The numbers m, n, and p in that order form a geometric sequence. So this is very important to note. These numbers form a geometric sequence, right? Prove that x is a non-real number. So we all know a non-real, the discriminant is less than 0, right? So that's the aim. We need to find a discriminant that is less than 0. So a discriminant that is less than 0, it means that the solution must be negative. Right? So whatever solution we find in this problem, it must be negative. So we were told that m and n and p are a geometric sequence, right? So the purpose of the problem, it is to prove that x is a non-real, right? So let me write the purpose, which x must be a non-real number. So that's the purpose of this question. So the first step that you're going to do here, because we were told that m, n, and p are geometric sequence. So what is a geometric sequence? Geometric sequence has constant ratio, right? So if this is our term number 1, and this is our term number 2, and this is our term number 3, then the constant ratio would be t2 divided by t1 is equals to t3 divided by t2. So what is our t2? It's n divided by our t1, which is m, equals to our t3, which is p, divided by t2, which is n, right? So what you're going to do here is you're just going to cross multiply, and we will have n multiplied by n being equals to m multiplied by p, right? So we will have n squared here being equals to mp, right? So this is what we are getting in this small problem here, is that n squared is equals to mp. So we might need this expression. So let me write it as equation 1. Remember, we want the discriminant to be less than 0. So the discriminant is equals to b squared minus 4ac. So I want us to look at what's inside the square root, right? Because that is the discriminant, whatever that's inside the square root. So this is what's inside the square root. It's n squared minus 4mp. So we're just going to write that. So that is our discriminant. So our discriminant is equals to n. So our discriminant is equals to n squared minus 4mp, right? And remember, n squared is equals to mp. So you can substitute, whether there's n squared you can put mp, or where there's np you can put n squared. It's up to you. So I'm just going to put mp where there's n squared, right? So instead of writing n squared, I'm just going to write mp. So it's mp minus 4mp. So this is still the discriminant, and mp minus 4mp is the same as 1x minus 4x, right? So please don't get confused. So here I'm just going to have minus 3mp, right? So the discriminant is complete. So we're having the discriminant of minus 3mp. And the fact that there's a negative sign, it tells us that this discriminant is negative, right? So it's less than 0. So you can conclude and say minus 3mp is actually less than 0, right? Making the discriminant to be less than 0. So whenever the discriminant is less than 0, it means that it is a non-real, right? Non-real solutions of x, right? So therefore it concludes that our x value is a non-real number. So that is the solution of this problem here. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.